Okay, so yeah, can you see my video? Oh, sorry. I didn't mean to turn it off.
There we go.
Yeah, we're going to continue from where we where we stopped last week.
Mhm.
But before we jump right into it, I want us to take a quick recap of what we did in 5 minutes so that we see how the next section build on that. So from last week, we talked about we look at the syntax, the Python syntax, uh, the how can we perform arithmetic operations and how do we store the values in variables, and then we see how to format the output. We look at f-string formatting. We look at string format, and we look at the old formatting syntax. Then we talk about the data types. We look at the different data types that we have in Python. The basic one, the string, the integers,
Mhm.
the list, and all that, Boolean. Then we look at conditions and how do we control the flow of our codes. Then we look at loop, right? So these are the codes from last class.
Mhm.
We look at what are the valid variable names, and this is the output formatting that I talk about. The string modulo, the string format, and the f strings. We look at the data types, we look at the strings, and then list, integers, boolean, and we talk about conditions, and then we look at the loop statement. How do we, execute tasks many times? And then this was where we stopped
Mhm.
in last
Mhm.
class. So now we'll continue by looking at more data structures. And we're going to see why it is important to understand the particular data types that we are working with. Um, so we talked about lists in the last class, but we're going to look at um, more how do we work more with lists, and we also
Mhm.
look at other data structures like tuples, sets, dictionaries, and look at what are the differences between these data types. So let's start. Um, we saw how to create lists and how to index. We remember we said lists are, Python generally is zero indexing, right? So we start with zero and start counting depending on the position that we want to stop. And then we can also slice from the beginning to a particular end.
Mhm.
And we look at the different ways we can modify a list. We can append, we can remove, we can delete, and all that. These are the modifications. We can nest a list inside another list. So we say that this 1, 2, 3. This is a list, right?
Mhm.
We can create another list that will be nested. So let's say we have 2, 5, 7. So we can now nest these two lists in another list. So now this is called a like list of a list. So we have a list, right? And inside the list, we have another list, right? So these are list of lists, and you can see we have it printed in a way that it has two brackets. So you can determine the dimension of a list by looking at the number of square brackets that it has. This is very important
I see.
when we are like dealing with, complex data structures, like
Mhm.
especially, in machine learning and deep learning, we want to have a 3 dimension, and this is a dimension, we call this dimension of the data. So this is a two-dimension. This is one-dimension data. This is a two-dimension data. We can have three-dimension and all that. So
Oh,
we can nest
sure.
the list inside the list. And how do we, we say that if we have one list, right? Let's say just this. Let's say dimension one. This is one dimension. If we want to
Hmm.
index the if we want to index or we want to take the element in the second position, how do we do that? Let's say this two.
That's a it's a one.
Yeah, that will be
The
D1 and that will be one.
one.
So this takes two. Now,
Okay.
now for this, which is a two-dimensional list, how do we take the same elements now?
How do we keep them all, or how do we reference that one?
How do we take it out? How do we index the second element? This two, we want to
I
take out this two. How do we do that?
just as a guess, I think we have to use two brackets again, and then just put a that way it tells it that it's a list within a list, and then use one again.
Exactly. So that
Okay.
means we have to use, now we know that we have two dimension. We have to use double brackets to index. So the first index value will be the position of the first element of our list of list. So now
Hmm.
this is the first element in our list, right? We'll call this 0. And then we now want to take the number 2, right? So that will now be
Hmm.
1.
Oh, see, I didn't think of it that way at all. I thought we would just do like double brackets on this side, double brackets on that side, and in the middle I would just do one. But
And
instead you're saying zero because out of the list of lists, it's the
mhm,
first one and not the second one. So
exactly.
then we're just creating a reference for the first chunk
Mhm,
or the first list and then a reference inside of the first list.
exactly. So that's how we
Okay.
reference it. So if we want to, can you tell me, let's say I want to print the last elements of this second
Hmm.
list. What will it be the indexing?
It'd be dimension two, and then the first bracket, it would be one, and then the
Hmm.
second bracket, it would be two.
Exactly.
Great.
Perfect.
Cool.
So this is how we index a list of a list.
Okay.
Um, so list comprehension provides a easy way to iterate over a list. Um, this becomes very handy when we are creating another list from element in the list. So what I mean by this is that let's assume that we have D1, right? Our
Hmm.
D1 is 103. Let's say
Hmm.
we want to um create
Hmm.
another list from this list that will be
Hmm.
the squares. So this is 1, 2, 3. Now we want a list that would be squares of each element, D1 squares, right? How can we do that? So we can use list comprehension. We talk about for loop, right? If we want to use
Hmm.
a for loop, we'll say for I for number, let's say for number
D1.
in D1, exactly, D1,
D1. Okay.
right? You can now say number asterisk number. Now, to do
Oh.
this, exactly, but to do this, we need to first create a kind of empty list. So let's say our D1 square, let's say D1 square equals this. Why do we create empty list? We created empty list because we want to start appending the result. Remember that for is an iterative operation. It's going to loop over. It's going to go perform one um, operation and then do another operation on this on the next sequence. So if we do this, we have to append the results.
Hmm.
So we say number um, d1 square dot append.
Oh, that's right. And so this is where it always gets tricky for me, is because just conceptually, so I can understand we made an empty list because we
Mhm.
want to put it somewhere.
Exactly.
And then on a for loop, we're going to define any random variable, which we're using num in
Mhm.
our list because we have numbers. And
Mhm.
then in the dimension one.
Exactly.
And then the square, instead of doing num times num, we're doing d1 underscore square. No, we're doing num times num still as a function,
As the
but we're
operation,
as an operation,
not a
but we're
function.
not a function,
Yeah.
as an
S-
operation. But
Exactly.
we are appending.
We are
We're
appending
appending.
to the empty list. Why is it important? Let me show you
Oh,
something.
okay, okay.
Let me show you something. Let's say that I want to print this. I'm going to write it for number in D1. Oh, sorry. For number in D1. Oh, sorry. For number in D1, I want to print number asterisk number. So you see what happened here is that the first time this is our D1,
Mhm,
1, 2, 3. So
mhm,
it iterates over the element of the list. The first element is 1. Then it performs this operation. Number times number is 1 times 1. Then it prints this operation, right?
mhm, mhm,
So the same thing is going on here, but instead of printing here, what we say is that after you perform this multiplication, this square operation,
mhm,
append the result to this empty list.
mhm, mhm,
That
mhm,
means, our list is empty. Initially, there is no value. So when instead of printing here, right,
mhm,
it just appended the results to this list. Then it goes to the second number. It does the multiplication 2 times 2. Instead of printing again, what does it do? It append the result to D1 square. And mind you, the result D1 square, after the first operation, we have this 1.
mhm,
So
mhm,
after the second operation of multiplying 2 by 2, it append the result 4 to the element in the list already, which is 1. And then now it now goes to the third values in the list, which is 3. It performs the multiplication and append to D1 square. Does that make sense?
It does. It makes sense.
Okay, now this is um so then after that, remember when we I told you in the first class that indentation is very important in Python.
Hmm.
All the statement inside this for loop will be executed um in the looping. But the moment we go out of the indentation, then it is not part of the looping statement. So we can now print D1 square, D1 square. So
And then
basically,
it'll be the same. Okay.
yeah, on the
Right,
phone
right.
line.
And it's interesting because when you print it that way, it appears as a list, but if you print it lower, it appears as what? What is that down there?
So what this one is doing basically is that it is just repeating this print statement. It is just
Hmm.
printing it straight. Like this is not a list. This is just like individual print statement. This is the first print statement.
Okay.
This is the
Okay.
second print statement, and this is the third. And you can see the importance of appending because now we can
Hmm.
take our list and then maybe do
Hmm.
something else with it. But this is
Right,
just a
right.
printing, just showing the result. How you get that?
Okay. Yeah,
Yeah.
yeah, yeah. Yeah,
So
and when we think about appending, like for an assignment in Classic, for example, we want to append to a list when we're trying to recreate our data frames, right?
exactly. That's right.
Okay. Okay.
That's right. Now, why did I take time to go through this for loop for a list? Is because I want you to appreciate the value of list comprehension, the importance, the significance of list comprehension. The same operation that we did here using the for loop, now a for loop with a list, we can do that using a list comprehension. And to do that, we'll just say D1 squares. Remember, the D1 square we calculated using this method is called D1 underscore SQR. Here,
Hmm.
I'm defining another variable called D1 underscore squares. But I want to get the same result. Basically, I want to
Okay.
still get a list of squares
Okay.
for the values in the list, right? So what I will do here is I'll just use my list, my square bracket for a list, and I will say that now this is it. For number in what is the list? What is the list name? D1, right?
I see. Okay. Hmm.
Then I'll just
Hmm.
put the operation here. Number asterisk number. This is
Oh,
it.
interesting. Oh, wow.
Exactly. This is list comprehension. So I just put everything for number in D1. This is the operation, number asterisk number. Now let's see what D1 squares is about. It is the same thing.
Hmm. List
See,
comprehension. That's what it's
this is
called.
list comprehension, exactly.
Oh,
So
wow. That's a lot cleaner.
very cleaner. So
Yeah.
it becomes very handy. It actually provide a very simple, easy way to iterate over a list and create another list or perform an operation instead of, for like we did here. So this is just one line and we get
Hmm.
the values instead of going over this. So this is very important. I mean, this is very used. It's commonly used for in data science, right?
Yeah. Hmm. Hmm.
Um,
That makes sense.
so this is list. It is very useful to store list of values and work with them later. Um, then we'll go to tuple. We want to see the difference between a list and a tuple. Do you have any questions before we go to that?
No, no, I understand the basic concept of what we're talking about. Of course, I have a lot of questions about, how this applies later, but I need to know this first better, right? And
Okay.
I need to practice it. So yeah.
Okay. All right. Sounds good. Okay. So we showed, now we'll move to tuple. We showed in previous sections that lists and strings have common properties, such as indexing and slicing. The reason is because they both are sequence data types. They refer to them as sequence data types. We have another data type. Tuple is another sequence data types. Um, Tuple can be created similar to a list. The difference is that instead of using a square bracket, we use parentheses or round bracket.
Hmm.
Um, let's say that x equals to, um, let's create name, Nahim, Gerard, Gerard, um, okay. Now we can, this is different from the way we like, they are similar to the way we create a list, but the difference is that we use a parenthesis. Now, if we find type of X, we see it's a tuple. It's not a list.
Hmm. Hmm.
So what's now the difference between a tuple and a list? Where do we need to use a tuple and, you know, when do we need to use a list? The distinction between a list and a tuple is that a tuple is immutable. It is unchanged, like the values in the tuple cannot be changed. You know, for instance, if we say that if we want, we can still index because it's a sequence data type. We can still index a tuple. We can say we want to get the first element in a tuple. It is going to give us 9.
Hmm.
It's going
Hmm.
to give us the first element. Is Python is zero-based indexing. But if we want to change the value of the values in a tuple, we are going to get an error. Let's say we want to assign instead of Nahim, or let's use An because okay, it's fine. Instead of Nahim, we want to put Deepti. We see we get an error, and the error is type error. Tuple object does not support item assignment.
Hmm.
Remember, for
Because
list, this is not a problem for a list. We
right,
can
right.
we assign values. Let's say that um for instance this
And that's what you mean by immutable, because with a tuple, we cannot reassign the
exactly
position. Uh-huh.
exactly.
Okay.
So, but if the element, if this is a list, we have no problem. We can change the values. Let's say we want to turn this thing back to a list, right? We can turn it to a list by saying that X list. Do you have an idea how we can change this tuple to a list?
Yeah, isn't it? Well, it's not D type. I don't know the command.
So the I we covered that in the last class, and I think
That's right. That's right.
we just use the data type name. I think we do. Yeah. So you can create a list by just putting the type of the data type. So it's going to convert it into a list for you or the any data types. I can't find it here, but I think yeah, we'll cover something like that. Anyways, yeah. So let's go. Now I want to convert this tuple to a list. I will just say list, right? That's the command. I'll just type list, right? And I'll put
Uh-huh.
the value X. Now, if I find the type of X list, now it is a list.
It's really that easy to convert
Yeah, it is. Now you can see
it.
it is a list. Now,
That's ridiculous. Uh-huh. Okay.
the
Okay.
same thing that I did that gave me an error here, I want to do
Hmm.
it again, which is to change um, the first element to change the value, which is mutating the values. I want to change it to Dipsy. Then I want to show the value. You see, there's no problem.
Yeah. Yeah.
It does.
Yeah. Okay.
So this is a difference between a distinction between a tuple and a list. And it's very important, especially when you know that I don't want people to change the values in this particular data types. This variable that I'm storing, I don't want to change the values by accident. So instead of making it a list, we make it a tuple. And you see,
Hmm.
this is the common error types that we would see when we are doing analysis. And then you realize that, well, I want to change. And you see something like, no, this data does not support item assignment. Then you know that it is either a tuple or an instance of a data type that does not support, that is not mutable. Did you get that?
Okay. Say that again,
So,
because the language was a little bit hard for me right there.
yeah, so what I mean is that so the mutability, the ability to change the values of a data type
Hmm.
depends on the type of data. So
Hmm.
if we create a list, then we know that we don't have any problem changing the values in a list. We can
Hmm.
reassign, we can change the values,
Yep.
but if it is a tuple, we know that now it is not going to allow us to change the value. So if we are working and we see an error of this type, that
Hmm.
this particular object does not support item assignment, then we should look at the types of the data we have, or the data types for the particular variable that we are working on.
Okay, great.
So,
I got that.
so we say that um, a tuple is not mutable; they are immutable. However, they can contain mutable objects, right? What we mean is, we say, let's say, x again is tuple of um, Nahim. This is the first value, right?
Hmm.
Let's say the second value now is a list. We say 1, 4, 5. And then the third value is, let's say, another integer, 10. So this is a tuple of three values, right?
Hmm. Hmm.
We cannot change any element of this tuple. We can't change this first element. We can't change this second element itself. And we can't change this third element. However, the second element is a list, right? But
Hmm.
a list is what is mutable, right?
Uh-huh. Okay.
So we can, if we try to change the second element itself, let's say the second element is x1, right? To be equals to, let's say, instead of 145, we realize that it shouldn't be a list and we want to change it to maybe name. What will happen?
It won't allow that
It will not
because,
allow that exactly
yeah.
because it is not
Okay.
mutable. However, we can change the values in this of this second element because it is mutable. The second element itself is mutable. So to do that, we will just say, okay, give me the second element, which is a list, but then I'm not changing the second element. I am just changing the value in the second element, maybe the first value in the second element. Oh, this will be 0, right? You get that? This
Yes.
would work. Now, there's no problem. And if we look at our X now, we see that what it does was it doesn't change the second element. It
Right.
only changed
Just
the
adds it.
first value of the second
Okay.
element. So tuple
Right.
itself is immutable, but it can contain mutable objects. So you can,
Now, in those mutable objects, is it just a list that's mutable within a tuple, or is there many other types?
oh, there are other data types that are mutable.
Okay.
Um,
Okay.
we can also we'll see a dictionary also. We can
Oh,
change
sure.
the values of a dictionary.
Uh-huh. Okay.
Yeah.
Okay.
So
Okay. And a tuple can be any length, right?
of course, yeah, it can
Yeah.
be any
Okay.
length. Yeah,
Okay.
it can be any length that you want. So how do we get the um the position and indexing? I mean, index and corresponding value of a sequence when we are looping. Sorry. How do we get the index and corresponding element of a value when we are looping? Let's say that we can say
It's useful to
for
position index
name,
sequence
or let's
terminator.
say for value in, this is x, y.
So enumerate is useful to get the position index and
Sorry,
corresponding value of a
this
sequence
is this
during
is a
looping.
typo. Yeah, position index. You can say index or position, y. I should put this in brackets. What I mean is that, remember that when I wanted to, when I was iterating over this list, where is that for that I created? Okay, yeah,
Right there. Mhm.
for number in D1,
Hmm.
Here, I only get the values 149.
Hmm.
What if I want to like, okay, I want to get the index, the position of each of these elements instead of printing just the squares like I print here. In fact, I'll copy this. I'll copy this, just the same um this, and I will use it here. Now, you see, for number in D1, I printed the 149, right?
Hmm. Hmm.
Now, what happens if I want to like print, okay, let's say instead of printing the 149, I print just the number, not the square. Instead of printing the square, I print 123. Now,
Hmm.
what happens if I want to print not just 123, but I want to attach the position that, okay, the index at 0 is 1, the index at 1 is 2, the index at 2 is 3. To do that, I can use for so I can use enumerate. So to use enumerate will just give us the index and the value. So I'll just say for index, comma, value in, oh, sorry. I know it's a bit, I'll break it down. Now, I use enumerate here, function, and I put the list inside. What that does is that it does not return just the value. It returns both the index and the value. That's why I have two parameters here, index, comma, value. Now I can now print, what do I want to print? I want to print index and then print value. You see what happened?
Hmm. Hmm.
So what it printed is,
Hmm.
it printed index 0, then the value is 1, the index 1, the value is 2, index 2. This is,
Do
this
you
is,
do
okay.
you have to use the word index for it to
No,
understand
it
just
has to be, it
index?
can be any value. It can be IN, it can be I,
Oh,
it can be
okay.
I.
Okay. So it just knows that the first one is the index value,
Exactly. That is the,
regardless.
exactly, regardless. I'm going to, let's
Okay.
see,
Okay.
um, Python, Python documentation, Python documentation. Let me search for enumerate here. Enumerate. Now, you see, this is the syntax. You call the enumerate and you call the iterable. So iterable are like any object that you can iterate over. All
Hmm.
right.
Hmm. Hmm.
So it can be
Hmm.
a list, it can be a tuple, it can be a string. So it will return an enumerate object. So you say iterable must be a sequence, right? Which is, it must be a list or an iterator or some other object which support iteration. So what it does is that it
So
returns
it will enumerate will return the index and whatever is next to that index,
exactly,
no matter what it's called. I don't even need to call it I,
exactly.
because enumerate already
Mhm,
knows. Okay.
mhm,
Okay.
exactly. So you see what they do here? They created a list, spring, summer, fall, winter, and then they
Hmm.
enumerate it. So what enumerate does is that it
Hmm.
just return a string, I mean a tuple of the index value and then the value. You see?
Hmm.
So we have spring, 0, 1, summer, 2, fall, 3, winter. So they put this in the list.
Yeah, and they're just saying they just put it in a list. So they're
Yeah,
just saying
exactly.
list.
Mhm.
Yeah. Oh, yeah, that's neat.
All right.
Uh, okay.
Now let's go to sets. Sets are an order collection of elements with no duplicates. I mean, this is the important feature of set is that it does not allow having duplicate values. It does not support that. So if you have a value that has duplicate and you put it in a set, it's going to remove the duplicate and will just return one value. Um,
It
I think
will
what
only return what it won't
it
give you an error.
it won't no, it will not give you an error. It will only
Okay.
return the same element or the same object, but the duplicate will be removed.
Oh, okay.
Yeah. What I want to do is that I think I created some variables before names here, right? So I'm going to run all this thing again so that I have my variables. I'll just run all the, I think I have an error somewhere.
Hmm.
Yeah, all this. Okay. I think I'll just create the names again. I'll just call it. Yeah. Okay. I want to show you something. Yeah. Let me define names, which is a list, and we have three values, the name Gerard and Han. I try to I try to use the same examples over and over again so that you get used to the objects or to the values, and then you see how the properties are changing with the different syntax. That's why I've been using names, I've been using the same values all over again, and I find it to be very helpful. And this is the same approach that we are going to take when we are building or we move into machine learning. I'll try to use one data set that would most likely support regression and um, classification and all that. So just be used to the data and then would not, because one of the things I feel like it's very challenging with learning is that you first need to learn, know the data set and then try to now start thinking about, okay, what can I do on the data set? Anyways, but that's when we get to machine learning. Okay, now let's define names variable. Now, what I do here is that I'm appending another value to this name, right? And for
Hmm.
list, we don't have a problem. It's going to append the name to it. So you see now we have
Naeem, Naeem.
Naheem,
Uh-huh.
Gerard, and Naheem.
Uh-huh. Hmm.
Now, if we call set on the names, what happens is that it's going to take the list and is going to, because it doesn't support duplicate, is going to return just one name. And another thing is that the order might change because set are unordered collection of elements. They are not order. So it might change the order. It doesn't keep the order of the values. So let's do that. And you see what we have. Now we have Anne, we have Gerard, we have Nahim. So it changed the order. It doesn't keep the order like we have in the set, and it
Hmm.
removes the duplicate that we have in the
Hmm. Hmm.
in the list. So this
And
is mhm,
mhm. I can see why this would be helpful, but I also wonder as when you're removing things, if you're not removing the associated data, like you were talking about maybe in future uses, like when you're creating a set, for example, just to eliminate all the duplicates, I
mhm.
wonder how that affects the rest of your data
Yeah,
in your
so
in your
so so that's why it is important to really understand the the data type,
mhm,
and because the different data types support different things and they are useful in different scenarios. So
mhm,
if, for instance, um, most of the times you don't want to use set for your list of values that you know that each values are important. So you don't want to use set for that. That's why list is there. List is okay. But a use case for set is when you want to create unique values. And it's
mhm,
mostly used in databases, like when for instance, users has to be unique. And that is what they use to set to store usernames most times. That's
Uh-huh.
why
Uh-huh.
you are creating a user, you are registering in for an application or something. They are going to
Mm-hmm.
check, does this name exist? If this name exists, we cannot take these other names again. It is unique. There has to be just one username for this thing. So that's why
Mm-hmm.
it's important to understand the data. Data structure is very important. Understanding the different types of data and the kind of operations they support and what you can do with them is going to really go a long way to help you to really understand what is going on in your analysis and what data types to use.
Mm-hmm. 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 And that's okay. Yeah. Yeah, we can continue on. I'll understand more about it as we go, I'm sure.
Yeah, if you have a question, we can ask now.
Okay. So for this set, obviously I noticed that we're using curly brackets, and that's kind of a dictionary. So are we creating a dictionary from a list?
Okay, so the way to create a so the reason why I did not use a call, here I just call set because I converted a list to a set. But if I want to like create a set from beginning, I'm going to use a curly bracket, right?
Oh,
And I
okay.
get your question that we are using a curly bracket, which is the same. We use curly bracket when we are creating a dictionary as well, right?
Mm-hmm. Mm-hmm.
So it's, I would say that a list is similar to a set,
Okay.
but the difference is that you can say a list is a set of key value pairs
A list is a set of
of
key
key
value
value
pairs.
pairs. So,
Yes. Okay.
and in fact, that takes us to a list. But before we go to
Okay.
a list, let's finish
Okay.
our
Okay.
tax on this. Now cannot we cannot index a set because remember a set is not ordered, right?
Mm-hmm.
So
Mm-hmm.
that does not allow us to like indexing. So if we say that x0, we get an error. Set object is not subscribable. So you cannot index. Remember, for tuple, we can index a tuple, but we cannot mutate the values. Why? For set, we
Okay.
cannot index it because it is not ordered. Why?
Okay.
Anyways, we can join two set using union. You can do intersection of set and all that. Now, dictionaries. This is it. We say dictionaries are sets of key value pairs. And like you notice, which I like, is that it is created using curly brackets, just like sets. But the difference is that we have here a key. Remember,
Mm-hmm.
this is a comma, right? A comma
Mm-hmm.
is separating one value from another. But here we
Mm-hmm.
have, between the comma, we have a key name and then the value is Nahim.
Mm-hmm.
We
Mm-hmm.
have another one, key age, the value is 16.
Mm-hmm.
So this make it to be a set because instead of having just one value, we have a key value pair. So now you can see this is name Nahim, this is age 16. So it is a set of key value pairs. So it builds on set, but it makes things to be um it gives like more functionalities to set by allowing us to have the key and the value. So because we now have the key and the value, we can now mutate, we can change the values in a set, all right?
Because we have a reference. There's a way to
Exactly,
reference. Okay.
exactly.
And there's an order
And there is an
with
order now in this case because we've already like defined using the keys. Now we can reference
mm-hmm.
with the key with the key um with the key actually. We
Hmm.
can
Hmm.
reference a particular value using the key. So it's just like, okay, I want this value, but I know the key is name. So what
Okay.
important thing about dictionary is that the key is unique.
Hmm.
The key has to be unique,
Hmm.
right? Just like a set that has unique elements or unique values. The key of a
Hmm.
dictionary has to be unique, but we can change the values. Does that make sense?
Right. You can change the values. Now, can you create a set from a dictionary and will it get rid of the ability to change the values?
Um, you can you create a set from a dictionary? Let's try. I'm not sure. That's a good question.
Just for,
Let's
just
see.
curious.
So when we
Oh,
create, you
interesting.
see what happened?
Yeah,
It takes the keys and remove the values because I'm not
right.
supporting key value pairs. I'm only going to keep the keys for you.
Oh, interesting. Okay. And it reordered it, so therefore um you can't reference it. You can't
Exactly. You can
yeah,
index it.
you
Exactly.
can't index it. Right.
Hmm.
Okay.
Does that make
Okay.
sense?
It does. Yeah, that makes sense.
Okay. Unlike sequences, which are indexed by range of numbers, dictionary are indexed by keys, just like we see. Uh,
Hmm.
our X, this is our X, right? Let's see. Yeah, so to index this, we are going to use the the key X name, Nahim.
Uh-huh. Uh-huh.
So we can change
Okay.
these values here. Dictionaries are mutable. X name equals, let's see. Now, what does our X looks like? Now we see name, the T, age 16. Does that make sense? If we try to get, um, if we try to
Well,
reference,
I don't know if it does make sense actually. So X name, so we referenced name,
mhm.
but then it brings up everything.
So what happened is this is we are assigning, remember our X. We have the key
Hmm.
before
Hmm.
our X is a dictionary. We have
Hmm.
name to be Nahim.
Hmm.
We have age to be 16.
Hmm.
We can reference this name by calling X name X.
Hmm.
Instead of
Name.
using X0 or X1 like we do for
Right.
dictionary, we just use X name. And we can
Okay.
change the value by just assigning another value to name. X name equals to another value. We can say X name is
That's all we did. We just simply changed it.
exactly.
Okay.
We can change
Okay.
the age. Let's say X age now is no
Sure.
longer 16 because it's now DT. Let's assume DT is really old woman, 35.
Very
So
fun.
now we have a change
Okay.
here. Does that make sense?
It does. Okay. Yep.
Does that
Yep.
make sense now?
So the way that you reference and change things is just different
It's just
because you're
different.
using
Exactly.
key value pairs now.
Exactly.
Okay. Okay.
So if we try to reference with a key that does not exist, we're going to get an error, like we say 6, uh, right? Key error.
Hmm.
And you know, it's very important because when you get used to these data types, you'll be able to debug better. You understand?
Hmm.
It
Hmm.
it it
Hmm.
improves your skills of debugging because by the time you run into a kind of problem or error and you see you read key error, that means you give it, wait, I don't have a key called sex or gender
Hmm.
in my list. So you have to go and
Hmm.
check your list again. Okay, this is where the problem is.
Hmm.
So
Hmm.
understanding data types, data structures, it's a foundation of becoming a good Python programmer.
Hmm.
All right.
Hmm. Yes, that
Okay.
makes sense.
So if you call a list on dictionary, it returns a list of all the keys, just like set that return the
Hmm.
set of all the keys. All the keys. List will
But
return,
set will reorder and it'll
yeah,
disrupt it,
it will
but will
just,
list,
yeah, list will
but
keep. Exactly.
list will keep it all. Okay.
Exactly. Now we can also use key methods, right? We can use key. It will return the keys and list. They are doing the same thing. They are just giving
Hmm.
us the list of keys that we have in a dictionary. If we want to
Hmm.
get a list of values that we have in a dictionary, you have to call the values method, right? Let's say what I mean is
It'll say
x dot
everything that's paired. Oh, it's a
values.
oh, is that what I do? Do I do x dot list, x dot keys to call that?
Yes.
Oh, okay, okay, okay.
So x dot values, it's give us dipty and 35. I think
Okay.
maybe
And
we can
x dot keys would just
yeah,
be, yeah,
yeah.
right.
So we have
List.
dipty 35.
Oh, okay. So now we have a list.
Yeah. So
Hmm. Hmm. That's neat.
yeah. So
That's
we can
simple.
now instead of doing we can do dictionary comprehension with a key too. I mean with a
Hmm.
dictionary, we can also do dictionary comprehension like we do with a list, like for this and this, it will give us all those stuffs. Um Now instead of like getting the keys separate and the values separate, we can
Hmm.
use items to get both the list and I mean both the keys and the values.
Hmm.
Does that
Hmm.
make sense?
Both the keys and the values,
Hmm.
and will it return a list this way or will it return a list this way?
So it's going to return a tuple of list and dictionary. I'm sorry, I messed up. It's going to return a tuple of keys and values. This is what I
Keys and
mean.
values.
Yeah,
Okay. Okay.
exactly. When I say uh what is our X? Let's see what our X is. We have the keys name, the value is zip-t. We have the key age, the value is
Hmm.
35. If
Hmm.
we say
Hmm.
for let's say key value in
Enumerate.
X dot items. Remember, I say items is used to get key comma value when looping through a dictionary.
So would you use enumerate at that point?
If I use enumerate, I don't need to use enumerate again because I want to get the key and the value. So dictionary provide a different method for getting the key and the value.
Oh, I see.
If I use enumerate for list because I want to get the index, the position, and the value. That's why I use
Hmm.
enumerate, right? But here, I want to get the key and the value. So we have items for key value in, for key comma value in x dot items. I can now print, um, I can now print key comma value. So we just print the name is 50, the age is 35.
And X dot items. Interesting for key value. Once again, the key comma value, could you just put, could you get rid of both of those values or both of those words, if you
You mean
will?
like, can I use another value? Another
Yeah,
variable?
could you
Yeah.
just use A for both of those? Or does it have to be A comma B?
Yeah, I can use a comma b, a comma b.
Okay, but you couldn't just use A for A in X dot items, print A, and it would return the same thing. You have to use A comma B. Is that
So I
right?
have to use A comma B if I'm using items because items return a tuple of the key
Mm-hmm.
and the value.
Mm-hmm.
If I want to
Mm-hmm.
use one, if I want to get only the key, I'll just say for A in X dot keys. This will return just one value. And I'll say print A. You see, name,
Mm-hmm.
age.
Mm-hmm.
If I
Mm-hmm.
want to return only um the values, I'll say
Values. Yep.
for B in X dot values. Print B. So this will return the values,
Mm-hmm.
50 and 85. But if I want
So
the,
it's like when you do A comma something or X comma Y, for
mhm,
example, you're basically creating placeholders.
exactly, placeholders, that's the name.
Okay.
You get it. That is the name.
Okay. Okay.
So it's a placeholder for each of the items in our iterables.
Okay. Okay.
You asked a
Got it.
question which is interesting. If we say for A, B in enumerate, print A, B, what does it do? Instead of returning key values, it returns index position
Mm-hmm.
and the keys. So because enumerate really works with like when you have an iterable that can be indexed with index position with 0, 1, 2, stuff like that. So you can use that to get the index position and then the value, which is like a list or like a tuple,
Could
right?
could I do could I do list print AB?
Um, sorry, I didn't get that. List print.
List print A comma B? Could you put a list in front of the print?
Um, no, you cannot use a okay. Print. You print is yeah, but you can this you can't
I,
do
I
this.
just wonder if you can
You
convert it to a
cannot
list right
because
away.
you cannot. So print returns a non-type.
A
Exactly.
non-type.
Yeah. And you
Okay.
cannot convert a non-type to a list. So that's what happened. You cannot
Okay.
convert this
Okay.
print. So print
Because
doesn't return anything. It returns a non-type. It's null.
it is just an
Exactly. Just an
output,
output.
no type.
So exactly.
Okay. Okay. All right.
Does that make
Great.
sense?
It does. Yeah. Yeah. But I mean, it's tricky. It's one of those things that's like, well, why wouldn't it? But now it makes sense.
Yeah,
Yeah.
exactly. Exactly. Yeah, but I like this. It's okay. Yeah, yeah. Let you know what is it that is going on with why am I getting this kind of errors? What can I do to solve it and all that?
Mm-hmm.
I think we covered a lot of things,
Mm-hmm. Yeah.
and
Well, this has been very helpful.
this is going smoothly. So what I want us to talk about last for today is functions. Functions. Where are we? So this is where we have functions. And
Okay.
then next class, I might need to reorder this. Maybe we'll talk about errors and exceptions before we talk about input and output because we already talked about functions. We look at how we can look at exception handling inside our functions, but that's going to be the next class. Okay, let's go straight
Okay.
into
That sounds
functions.
good.
Okay, a function is a reusable set of instructions. A function is a reusable set of instructions that takes inputs, performs some operations, and often returns an output.
Mm-hmm.
So we see many inbuilt functions in Python, like print, which just return something to the user. I mean, which just outputs. There is no return.
Hmm.
We see
Hmm.
the len, which
Length.
find the length of an iterable. And so many functions are like enumerate that we saw is a function in Python, right?
Hmm.
And I think I mentioned the difference between a function and a method. So I think in last class. Anyways, well, we're talking about function now.
Yep. Yep. Yep.
Functions are defined using the dev keyword. So definition, short
Hmm.
dev. Although the power of a functions is in its ability to take dynamic parameter values, we are going to talk about that. Defining function without parameters is possible. So what I mean is, if you want to define a function, you can just define a function that prints hello world. Def, then you follow it by the function name, hello world. So then you use a parenthesis. The value, the purpose of the parenthesis is to take in parameters. Like we supply
Okay.
parameters, but then we might decide that we don't want to put any parameter. We just want to define a function. And the function for this one is doing just printing hello world. What happened when we run this?
Hello world.
Nothing happens. It's not going to print anything.
Oh, because we have to call
We
hello
have to
world.
call it exactly. So we
Okay.
just define
Okay.
it. It's not going to show anything. So
Hmm.
functions only runs when it is called. So when we say hello world, then it prints hello world.
Okay. Got it. Okay.
So why is it important to define the functions? It's one is that it allows us to like run codes many times and put different parameter values and change the argument and stuff like that. Um, so if so there are two words that are usually, used interchangeably in function, and they are parameters and arguments. So what's the
Okay.
distinction between the two?
I don't know.
So when you define, okay, before I go into that, let's see why it's good to write a function first for stuff that we'll be writing and running all over again. Yeah, I write another set of print statements, about four print functions. I mean, four print statement. What it does is that it says, hello, everyone, just an introduction. I am Naheem. I am 16. I'm a male. So when we run this, we have no problem. It shows us what we want to show. But what
Hmm.
happened when I feel like, oh no, I don't want to show this. I want to change the name. I'll just come here and say, okay, I am Deepti. I am not 16. I am 35. Then I am a female, right?
Hmm. Hmm.
Then we run it. I mean, this is this is not very this is not an efficient way of doing things. We have to go over
Right.
and change it again and run it again and all that. So when we
Right.
know that, okay, we could just write a function that do this. So what we need to do is just tell it what we want it to show, or the values, or give it the arguments. So that's why function is important. So here, what we want to do, you want to do the same thing, but with a function. So definition, def, keyword, function name is intro, and then, so we now supply the arguments. So arguments are the variables or the inputs of a function. They are inputs, they are placeholder of values in a function. But parameters, does that,
Place. Okay. So
sorry,
parameters are
let me,
parameters are placeholders of a function.
let me say that again. So when I
Okay.
say,
Okay.
I'll say it with this. When I say that dev is a keyword. Intro is a function name. I want to define a function that will take some input. So in here, I will say name. I need a name. I need age. I need um, gender.
Gender. Mhm.
Now, these variables that I supplied in my function are called parameters. They are the function parameters.
They're the parameters of the function because they call um well, all those things are defined as a certain thing, right? Whether they're
Ye-
key pairs or their definitions are, or their definitions if or no, I'm sorry, or their well, definition's this, but they're defined as something, and so we're just calling on them more or less.
So they are called parameters not because of their list or something. It's because they are meant to hold some values.
Uh-huh. Hold some values. Okay.
Yeah, and that values, or we can say parameter values, they can be anything. So the value they hold are called arguments.
Mm-hmm.
The variables themselves inside a function definition are called parameters. And parameters can be, they can hold any values that are
Mm-hmm.
defined within their scope. And in machine learning, this is something you see parameter search. We are searching for parameters and stuff like that, stuff like this. But then I
So
just want to make a
so
distinction between a parameter and these are two words that are just used anyhow. But parameters are like inputs that we use when we define a function. Uh,
mm-hmm.
and what they are meant to do is they are meant to be able to hold any values when we
Mm-hmm.
are calling the function. So when we are defining a function, we put in some parameters or
Mm-hmm.
inputs in the function definition. In our case, we have three parameters, and they are name, age, and gender.
Mm-hmm.
After we define our function, let's define our function. So I want to print all these things. I'll just copy.
So a parameter can hold a blank. A parameter can hold a what's the other word? Argument. But an
Exactly,
argument, but
exactly,
an argument cannot hold a parameter.
exactly. So parameters are holding values, and the values
Mm-hmm.
are called arguments.
Mm-hmm. Yeah, that
Why?
makes sense.
So hello everyone. I am now. I don't know what the name will be. I am name. I'm
Okay.
using print formatting. You remember? F. So hold the
Mm-hmm.
name here. And I don't know what the age will be. I'm using print formatting. Age. Let the F be here. And the F string. I am gender. Why?
Mm-hmm.
So now this is it. I have defined my function intro that would say hello and then introduce the person. I am this, I am that. So now if I want to call the function, I will call the function, I'll put in the name and then supply arguments. So
Mm-hmm.
arguments, remember, are parameter values. So the name now will now be, I'll say Nahim. I'll say age is 16. I'll say gender is male. Okay.
Okay.
So I'm Nahim, I'm 16 years old, I'm a male. I can change the age. No, I'm older. I'm 20.
How old are you really?
um, I'm 20. I'm 29.
29.
Mhm.
You're not 16.
I'm not 16.
Okay, okay.
Yeah.
Cool. That's a good
I'm an
age,
old
man.
I'm I'm an old man.
No, no,
I'm
you are a
getting
young
older.
man. Yeah, yeah, yeah. You're almost 30 though. That's
I'm
good. That means
almost
you're getting
next year I'll be 30.
okay, okay. Getting
Yeah.
large.
Yeah, so I'm 20.
Okay.
I'm male. So but then I can be a female. I'm not a female. So this is the usefulness of a function, right? It
Hmm.
makes we can reuse the function, we can put different parameter values, we can run it, we
Hmm.
can, you know, change the values and all that.
Yeah, that makes sense. That makes
One thing that we might do is if we know that, let's say for instance, we know that we want to set default values for the argument because here now we just put the name and all that. We can set the default values that if they call out, because if you call this function intro, what would happen if I call the function now? Let's say
uh
intro, let's say I put
uh
name to
it'll just
be
repeat. Oh,
Gerard.
name.
What will happen with that?
Oh, okay. So with name, it's going to repeat everything else. It's going to
Mhm.
say, "I hello everyone. I am Gerald. I'm 20 years old. I am female."
Okay,
Is
that's a
that
good
right?
guess, but that's not
Okay.
right.
Okay. All right.
So why what the reason it's not right is because we define a function and we'll put in some parameters. And the parameters, we didn't specify the value. So it expects that we have to supply the values in, because our function has three parameters. So it
Hmm.
requires that we supply those three parameters. So if we call the function with one parameter, we get error. You see, into missing two required parameters.
Oh,
I mean,
okay.
missing two required arguments, age and gender.
Good. Okay. Okay.
So we
Yeah.
have to, put the three argument. But what happened, what can we do to prevent this is we can say, okay, we want to set default values for our function. So to do that,
Hmm.
we'll just copy this again. I'm lazy, I don't want to type
Hmm.
this.
That works.
And I will say name. I don't know what the name is, but I think even if they don't put the age, I want you to use the default age of 30. And if
Hmm.
they don't put the gender, I think everyone that will be, maybe everyone that I want in my group is male by default. They should be male, I assume.
Hmm. Hmm.
So if I run this now, I define the function. If I call this thing again like this, what do you think will
Hmm.
happen?
I think it might work.
It will work because now name is a required parameter and then we put it.
Hmm.
But age are optional parameters. Why they are optional is because when we define the function, we already specify a default values for the age
Hmm.
and a default value for the male. So when they call the function and the user does not specify values for the default parameters, then it will
Hmm.
just use the default, sorry, yeah, it will just use the default values that we put there. So let's do it now. You see, I am Gerard, I
Okay.
am 30
Yeah.
years, I am a male. But what happens if I want to, like, I know that, okay, um, age, I know you are older, you are maybe 45. That's my guess.
46. That's right.
I'm very close.
You were. You were. Yeah.
So 46.
I'm an old man. Are you
Yes, I know.
kidding?
Yeah, so what happens is when we call it like this, what we are saying is that no, we don't want to use the default value for the age. We know the exact value for the age.
Uh-huh.
So I put the name, I put the age, but the gender, I still leave it. So it is going to like still give me the default values.
Yep.
So you
It'll
see,
still
I'm
give you the
Gerard, I'm 46 years old, I'm male.
predetermined.
Yeah.
So, Naheem, I have to go to bed soon. I gotta get up early.
Hmm.
Um, can we call it good for the evening?
That's good. That's fine with me. We are almost done, but that makes sense. We'll continue for yeah.
And then that way we can touch on a little more of this next time and then segue into the next section.
Yeah, that's fine.
Cool.
Yeah, cool. Cool, cool,
God,
cool.
that's great. This is really helpful. I really appreciate it.
Yeah, so we'll continue, yeah, in the next class. So just okay. All right. See you.
See, that's what happens when you're 46. You gotta go.
Yeah, man.
That's
Live,
funny.
live, live is catching up on us so fast.
Yeah. No, it's okay. No, yeah, it's fine.
Okay, okay, nice. I think you like the class?
Yeah, it's great. You're doing such a nice job.
All right,
And
thanks.
thank you for your time too.
Yeah, so yeah. So we're going to meet on Wednesday.
Okay. Yeah. Wednesday's good.
Right. Okay. Have a nice night and I will catch
How
you
do
soon.
you say thank you in Hebrew?
In 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 Hebrew or in Arabic,
Arabic. Yeah, Arabic's fine. How do you say
you
thank you?
say Jazakumullahu khairan.
Oh boy. Jazao Kumur. Kumur. What? Say it
Jazakumullah.
again.
Ah, let me bring something up.
Okay.
Thank you in
Or what
Arabic.
would you say? Yeah, what would you say? Would you say thank you?
Yeah, I mean, I don't really understand. Shukran lak. I miss that.
Chikwelak.
It's
Chikwelak.
shukran lak. Yeah, shukran lak. Shukran lak.
Chikwelak. Chikwelak.
All right.
All
All right.
right.
Nice. Yeah.
Have a good night.
Have a nice night. We'll meet
You
tomorrow. I
too.
mean on Wednesday. Bye.